Okay, so in front of us we have a GTX 1080 Ti. This is the FTW3 by EVGA. So unlike most of the broken cards we get, we're not going to start with a voltage and resistance check, as this is one of those half-working cards. If you try to use this graphics card as a primary graphics card, the monitor, I should say that the system will take about a minute to post, and the monitor backlight will turn on, but there will be no image, which generally indicates a sign of memory errors. But as a secondary card, this will either throw code 43 or crash on driver stall. So what we're going to do is, it's actually hooked up as a secondary GPU. So let's actually try to get into Windows, install the drivers, and see what happens. So if you don't know, an AMD card is used as the primary card, so the GTX 1080 Ti is a secondary card, and so in a moment after the driver is installed, we should either have a code 43 or a crash on driver install. I'm not sure which, as I haven't yet tested this card. And has it frozen? And yes, okay, so I'm moving the mouse, but nothing moves. So, and the caps lock key is unresponsive. So yes, it seems like our 1080 Ti causes the our computer to freeze when it attempts to load the driver. So let's just and there's our blue screen. So the 1080 Ti causes the system to blue screen of death, and as you can see, it says page fault and non-page error, where this is likely a memory-related error. So anyways, let's go ahead and run a program called MATS, which I have a guide video on, which I will link in the description. Okay, so at the moment we're looking at our MATS reports. I went ahead and ran MATS off camera. So anyways, this card, as you may remember, has two distinct symptoms. The first of which is that it takes about a minute to post if used as a primary card. Unfortunately, I didn't show this. I kind of regret not showing this. But like I said, it takes about a minute to post, and when it posts, the backlight of the monitor turns on, but there's no image. So the second hint is the fact that when it's used as a secondary card, causes the system to become unstable and crash. I think you should have seen the blue screen. So anyways, with that in mind, we went ahead and ran MATS, as MATS is, as those two hints suggest, we have memory problems, and MATS is a leaked internal NVIDIA tool used to test for memory-related problems on select NVIDIA cards. Anyways, so looking at the MATS report itself, this is what it generates. We can notice that we have memory errors on bank E0. This is a bit of an important detail, because the thing to note here is that it's only E0. What you typically see on these Pascal cards is that if you have memory problems on multiple banks, it's usually not the memory bank itself at fault, but rather the memory controller, in which case you have a dead core, since the memory controller is built into the GPU itself. So looking at the failing bits, this is 16 to 23, so these are the second last 8 bits. Typically, if you have a dead memory bank, the bits fail in quarters, as these memory banks have 32 bits to them, and they are subdivided into 8-bit sections. Looking at the actual errors themselves, the thing to note here is that they're not particularly random like you see on some shorter memory modules, and it's not the OOFF kind that you see on some cases of dead Pascal cards. Instead, what we have is something that's kind of in between. So the thing to note, as I mentioned, is that if we look at, let's say, the errors themselves, we have errors on the third and fourth value, as well as the last two values. And that's the only places we have errors. The first and second, as well as the fifth and sixth value, are always 0, as they should be. So we have, again, a bit of an isolated error to, I guess, the second last 8 bits, which maybe suggests the second last bits encode for the actual data between, again, the third and fourth value, as well as the seventh and eighth. But anyways, enough with the theory crafting. So since we have problems on bank E0, let's go back to the card itself so we can identify which bank is E0. Okay, so as you can see, the card is fully disassembled, and as you should have seen, we have memory problems on bank E0. So if you don't know the ordering is as follows: A1, A0, B1, B0, C1, C0, D1, D0, E1, E0, F1, F0. So this is E0, and by extension our problem memory bank. So for a card with memory-related errors, there are two things that you want to check, or at least for this card there are two things, but at least one thing on all other cards. So the first thing you want to check is the memory phase itself, as sometimes when you have a faulty memory bank, the memory bank itself goes short, or if it's the memory controller ends up being the source of a short. But in this case, we have 68, 69 ohms, which is perfectly fine. And then for GDDR5X in particular, you want to be checking 1.8 volts, as 1.8 volts is used as the pump voltage for a lot of GDDR5X memory modules. And as you can see, we have 812 ohms, which is perfectly fine. Since I've never covered the FTW3 before on my channel, I should note that these are both 5-volt power rails, and this is the PEC rail over here, where the PEC rail is typically 40 plus for 1080 Ti, and in this case, a very high 102 ohms. But anyways, since we have memory problems on bank E0, let's go ahead and replace it and see if it becomes any more functional. Okay, so as you hopefully saw, or at least part of, I replaced the memory bank at E0. You can tell by the tone that it's a bit different from the other ones. Anyways, let's go ahead and actually, no. So, before we turn on the card, we want to check for short on 2 power rails. So first we want to check for short on the memory phase, as obviously our new memory bank connects to the memory phase itself, and we have 69 ohms, or 670 ohms, perfectly fine. And now we also want to check for short on the 1.8 volts, as GDDR5X uses 1.8 volts as its pump voltage. And again, we have 810 ohms, which is perfectly fine. Okay, now let's go ahead and turn on the card and see if it becomes any more functional. And as you can see, we have a BIOS splash screen. So the card is now in a bootable state. Let's go ahead and put it back together and stress test it. Okay, so you can see the card's running game. It's a pretty nice looking card if you ask me. So anyways, if you have, let's say, a Pascal card where it artifacts, throws code 43, or takes about a minute to post, where when it does finally post as a primary card, it gives you a backlit monitor with no image, there's a good chance that you have a problem with the memory itself. This is, I would say, the most common cause for those symptoms on a Pascal card. So anyways, if you have one of those cards, you want to be running a program called MATS, which will be linked probably above. Anyways, so like I said, you want to be running the program in that guide video, and then using it to diagnose your card, as it will tell you exactly which memory bank is bad, provided of course you have a compatible card. But anyways, I hope you learned something watching this video, and if you have, consider supporting the channel by using one of the donation or Patreon links in the description, and hopefully I will see you in the next one.